The next part is about the shape of simple molecules or polyatomic ions. When we are going to predict the shape of molecules, we need to have the basic electron diagram first. That is what we have practiced before. And then we need to find out around the central atom how many or the number of electron clouds present. This is not about the bonding electrons, it is about the electron clouds. So then after we have this one, we can consider about the spatial arrangement of the electron clouds. Now, the spatial arrangement of the electron cloud is not the shape of molecule. In fact, we need to consider about whether there is any lone pair, and then this one, the spatial arrangement of bond pair of the atoms, we need to consider about it. So that's why when we take a look about BeF2, now you can see for BeF2, Be will have 2 electron clouds only for the central atom. So this is the first one, the second one. Well, when we have these two, then when we have 2 electron clouds for the central atom, then they have to arrange linearly, because electrons bear negative charge. This electron cloud bear negative charge as well. They want to repel each other so as to repel for the maximum. They will not interact much because negative and negative, they have repulsion. So I use another case, which is NH3. Now for the NH3, again, when we draw it, so it should get the 3 hydrogen atoms share 1 electrons each with the nitrogen atom. So we see that there should be 1, 2, 3, 4. Now, in fact, it should have 4 electron clouds for the central nitrogen atom. We should count all the electrons that contribute. So we should have 4 electron clouds. If there are 4 electron clouds, the electrons, they should be tetrahedrally arranged. So we say that the ammonia, the electron clouds, they are tetrahedrally arranged. As a result, you can see tetrahedrally arranged, and then here the shape will be more or less the same as the tetrahedron. And you can see that because the lone pair electron, we will not count it. We just need to think about the arrangement of the bond atoms. So we have 1, 2, 3, 4. As a result, it would be having stuff like this one instead of a tetrahedron or the tetrahedral shape. Hence, this one we will say that it is a trigonal pyramidal, a trigonal base pyramidal. This one, we don't need to think about the lone pair because we cannot see any atoms in the lone pair, so we can neglect it, and then we just need to count the bond atoms for the spatial arrangement. As a result, this is a trigonal pyramidal.